So linear regression problem. So what is a problem? So problem is we want to predict a continuous numerical value based on some features. Let's say IPL score, some demand prediction, some house price prediction, and some premium insurance amount prediction. So let's say we have a target variable y which is unknown that we have to predict, and the target variable y depends on some features f1, f2, f3, f4, which are the factors influencing the target variable. So by how much we don't know, so we need to compute the influence of each target for each feature on the target. So how do we have to learn this? This is the problem that linear regression aims to solve. So y equation says y equation becomes f1 w1 f2 w2, which can also be written as w1 x1 w2 x2 up to wn xn, and with the base value. So we have to learn this weight coefficients. How much does each factor influence the target variable? And base is just the base. Let's say if all the influence is 0, how much will my base prediction be? Let's say for a insurance premium amount, let's say the base prediction can be 20 lakhs. So this is the problem. So how do we approach the problem? So let's say we need to find a relationship between x and y, where x is just my feature, let's say number of what we can say, for a house price prediction, let's say number of bedrooms, and this is the price. So if I increase the number of bedrooms, how my price varies, by how much does my price change? So we need to find the relationship between x and y linearly. So if the relationship is linear, we draw a straight line that passes as closely as possible to the all the data points of y, so that my residuals, the errors that I'm making, is minimum. So let's say if I want to predict a new value for for this, so there should be line here on the line. So I would predict the point on the line. This is x is known to me, this is known, and this is unknown, right? So we have some n number of variables that are known to me, and I want to predict the unknown, and this n number of x variables are linearly dependent upon having a linear relationship with the y variable. So we can draw a simple line. So what is the equation of a line? So equation of a line is y equals to mx plus c, where n is the slope. Slope is nothing but delta y by delta x. So mx plus c, and c is the intercept. This is m1. So my equation would m1 x1 plus c. Similarly, we'll find the slope for for the feature 2, and similarly for feature 3. So now we just care about the slopes. So let us remove the intercept for now, and then how much influence does this feature has on the target variable, this feature and this feature, and adding all of these independent influences will predict a value, plus the bias of course will give me a value which would be my final house prediction. So this slope and intercept can be found using a statistical method also, and a gradient descent method also. So for the linear regression, the scikit-learn library uses OLS method, not the gradient descent method. So we'll see how OLS method works. So the OLS method how how it finds the slope between x and y. It computes the covariance of x and y and divides it by the variance of x. So covariance is nothing but just the summation, so that it is a difference between the xi minus x bar into summation of yi minus y bar, where y bar and x bar is the mean and variance is the x and is x. So we need to compute the variance and mean of the x variable and the mean of the y variable. So we can get the covariance and the the variance. But the slope derived using this formula will be unscalable, which not be having a standard scale. Why? Because we are using the entire feature values of the xi, and x and y variables can have different scales. Scales can be different of x and y. So the output depends upon the scale of x and y. So the range is not definite, it only depends on the scale of x and y. But if we use the correlation method, that is dividing by the standard deviation of x into the standard deviation of y, we get a value between -1 to 1. So -1 suggests there is a perfect correlation, perfect negative correlation between the variable x to y, and +1 suggests the positive correlation between x and y. Anything in between also suggests a correlation, but if a correlation is greater than 0.5, we consider it as a strong relationship, and similarly in the negative direction. So we are only concerned about the correlation with magnitude, not the direction. So the feature must have a correlation, a strong correlation with the target variable, so that it can predict or it can explain the target variable variance. Right? A gradient descent formula is also a way to find the slope of the line and the intercept. But for this simple linear regression, we use the scikit-learn depends upon this OLS method. So this is a one-shot learning method. One-shot learning. That is a simple computation. As why to take out a sword when we can use a knife? That's the thing here. So what are the limitations of using the OLS? So the limitations of using OLS are, first, it only works with the linear mapping variables when x and y are linearly dependent on each other. Like change in one unit of x causes some change in y linearly. Let's say y equals to 3.5x, or y equals to 1/2x, or something, y equals to 5x. So all these are linear, right? So for the linear relationship, we can simply draw a line so that all the x variables can predict my y variable. And scikit-learn uses the covariance variance formula for linear regression problems. Here's the thing. So thank you.